Hello everyone, my name is David and this is my first official video on YouTube. I'm starting a new project here for engineering students that just need a little bit of help and just need some help on the basics of engineering. So we're going to get started. This is nodal analysis. So before we get started, there are a few things that you need to know. You do need to know Kirchhoff's voltage and current laws. You do need to know basic components like resistors and voltage sources. If you want to learn dependent sources, that's great, but I didn't put dependent sources in this one. And finally, a general introductory knowledge of electronic circuits, as well as general introductory knowledge of measurements. So moving on, we're going to go with an easy 3-node problem. As you can see here, there are 3 nodes. We got a node here, a node here, and a node here. The first thing we want to do is reference a node to ground. Of these 3 nodes, which of the nodes is the best one for ground? It's up to you really, but most books like to put the ground right at the bottom or the middle of, if it's a diamond. In this case it's a rectangle, so we're going to put the ground reference here. So the ground is right there. So let's label these voltages. We're going to label this voltage V1 and this voltage V2. Now that we got the ground reference and the voltages already labeled, well, it's time to make our KCL equations. Remember, when writing KCL equations, you are writing in the form of currents. If there's a voltage hanging about, the answer is already in front of you. So like for example, if this current were a voltage source, you would not have to worry about it because the voltage, well, that's what the node is. The node is that voltage. But it's not, so we are not lucky enough here to solve this problem. Alright. And finally, when finding the difference in nodes, always do your target node first. With that, let's get to this 3-node problem. I'll move this up here for you so that way you can see both the circuit and the equation. Alright. So let's do the ins and outs first. As you can probably see, there are no ins. Most of the, well, all of the nodes actually are coming out, like so. So we can write our equation from here. Let's start with V1. So as you can see, we have 3 nodes going out. So let's do the out side of the equation first. We have 2 amps. Let's add on our V1 like so, and we got V1 minus 0 over 2K, the voltage over the resistance. Now you don't necessarily have to put minus 0 in there, but the ground is 0. Just remember that. And finally, remembering our target, V1 minus V2 over 2K equals, well, that all equals 0. The second equation, as you can see, there are 2 out points there, mostly in series it looks like. Let's go ahead and do the equation anyway. Well, first let's go ahead and eliminate the 0 here. And now the second equation. V2 1 over 1K plus V2 minus V1 over 2K equals 0. Just like we did in the first node, we put V2 first over 1K, the resistor 3 here, R3, and then we put V2 minus V1, which is over 2K, the exact opposite of what we did in V1. Alright, so now we're ready to solve the equation. First thing we're going to do is we're going to move this 2 over here to the other side. That way we can get our fractions and our whole numbers organized. Then let's multiply. We're going to multiply the first equation by 2K. And we're going to multiply the second equation by 2K. And that gives us the following. Alright, so after that we're going to combine terms like so, and then we're going to organize them as well. So we're left with 2V1 minus V2 equals negative 4K, and negative V1 plus 3V2 equals 0. Remember, K is 1,000 and 4K is 4,000. So we're going to solve this. There's an easy way to solve this. We can use Kramer's rule, but we'll save that for later. My favorite is elimination. Pretty much you know elimination in some basic math class, so I'm not going to go over it. I'm just going to go ahead and select the second equation here and double it. accordingly. And that leaves us with negative 2v1 plus 6v2 equals 0. We're going to combine the terms here, and we're going to come up with 5v2 equals negative 4k. And finally, we got v2 equals negative 800 volts. So we can plug that into our equation now, like so. And now we can just put our negative 800, I hope I said negative 800 earlier, and negative v1 plus 3 times negative 800 equals 0, and 2v1 minus negative 800 equals negative 4k. Well, I'm going to go ahead and solve this first equation now to solve v1. So we're going to do that now. And what we come up with is 2v1 is equal to negative 4800, and v1 is equal to negative 2400 volts. You can check the work, and you can check with both equations. So remember, know your nodes. So know where all the nodes are, make a ground reference, and KCL equations. Target node goes first in determining the difference in voltage. Let's try a do-it-yourself problem here. A little bit tougher. This one shouldn't be too hard though. 4 resistors and 2 current sources. You can pause here if you want and do it yourself, or we are going to continue with the problem. Alright, as you can see, we have 4 nodes here, and we are going to place a ground reference where we put it in last time, which is right here. Not too hard. Now that leaves us with 3 nodes. Here, here, and here. So now we can label these nodes, and we'll label them V1, V2, and V3. Now first we're going to write the equations. For this case, I'm going to go ahead and write the equations myself right here. You can go ahead and pause here if you want to write the equations yourself. Just follow what I did earlier in the video. Alright, so we have our 3 equations as such. So now the first thing we're going to do is move this 6 milliamp current source over like this, leaving us with negative 6m. That also allows us to organize the fractions from the whole numbers. Now, in this case, we're going to need a common denominator. Obviously, this is, again, basic math. If you do not know common denominators, check your basic math book. Common denominator for the first equation is 60k, and that leaves us with 3v1 plus 4v1 minus 4v2 equals negative 360. The second equation's common denominator is 30k, leaving us with 2v2 minus 2v1 plus 3v2 plus 3v2 minus 3v3 equals 0. And finally, we'll just multiply 10k to the third equation, giving us v3 minus v2 equals 30. Okay, combine terms and organize them like so. I'm going to put 0v3 and 0v1 here because obviously this is a solution 3 unknown equation. This forces us to use Kramer's rule. So first we're going to take the coefficients like so, and we're going to make this equation like so. So now let's get rid of the circuit for a little bit. Now, let's worry about the determinant. The determinant of the said equation here of coefficients. We do our determinant and we find out our determinant is 27. If you do not know determinants, please get a basic calculus book or math book that will teach you about determinants. Now we're going to take the determinant of V1 over we're going to take the determinant of the unknowns over the particular determinant here. So everything is over 27 like so. And we have replaced the first, second, and third columns of V1, V2, and V3 respectively with the whole numbers that we had, the other side of the equation. So let's go ahead and solve the first one here. The determinant of that equation is negative 1440, and the answer of that one is negative 53.33 volts. The determinant of the second one is negative 90 over 27, and the answer is negative 3.33 volts. Finally, the third one is 720, thank God, a positive number this time, over 27, and the answer is 26.67 volts. And finally, rate, comment, and subscribe. This was my very first video. Please tell me how you liked it. And we're going to work on the supernode next. Well, with that, this is David saying see you later.